Welcome to part 6 in this video series using the analog voltage AOI. In this video series, we're going to be introducing the analog voltage AOI. We'll also be importing the analog voltage AOI into the PLC project. We will then learn how to configure the AOI for voltage analog control. We will also explain the PLC tag structure the AOI creates that makes programming the AOI user-friendly. So let's get started with the analog voltage AOI. This will be our first add-on module that we're going to talk about in this video series. Here we have a graphic representation of our valve stack. The analog voltage AOI is the first add-on module left of the COM module. This is considered add-on module number 1. This will be an important concept to remember when configuring add-on modules. The next add-on module is considered add-on module number 2, and so forth. Up to 12 modules can be added to the left side of the COM module. The analog module that we're going to be working with has an example pinout here that will be important when wiring up analog signals to your analog add-on module. Here we can see pin 1 and 2 are dedicated to outputs, and pin 3 and 4 are dedicated to inputs. When working with the analog voltage module, we see that there are 4 analog inputs that are available and 4 analog outputs that are available that correspond to the pinouts that we showed earlier. Please familiarize yourself with the wiring of the analog module before proceeding. During this video series, we're going to be using an analog voltage and analog current simulator that we can use to simulate analog inputs. If you've been following along with us in this video series, we've been using this sample project called MAC. We're going to go ahead and import our add-on instruction for the analog valve AOI. This is done by right-clicking on the AOI instruction folder here and clicking Import. We've done this process before with the config module and solenoid control AOIs. At this particular time, we're going to click on analog voltage AOI and go ahead and import that into our project. At the particular time of this video, we're going to be using revision 1.0. This is an analog voltage 0 to 10 volt AOI. Once the add-on instruction imports, it will appear here under the add-on instructions folder as another AOI that is available to use. We'll also notice that it imports an SCP AOI, which is a scale with parameters AOI that is used in conjunction with analog modules. We'll also note that the AOI imports some more UDTs here. These are user-defined data types that are associated with add-on module. Let's go ahead and drag and drop our add-on instruction into an available rung of ladder logic over here. We will need to create a new rung of ladder logic for our add-on instruction to be imported. We can drag and drop our add-on instruction right onto our new rung and begin configuring it for the first time. Just like all the other AOIs, this particular AOI just lives on a rung all by itself and is active all the time. In other words, this rung is true with no other instructions in front of it. Let's begin configuring the front panel of the AOI now. One of the things to note is if you have multiple valve stacks, naming convention is important, and in this particular case we're going to call this Module 1 for the first analog voltage module here. The first tag instruction that we need to do is we need to give this a tag name that's assigned to this particular AOI. If we have another analog module installed, an analog voltage module installed in our solenoid valve, we would need to add a second rung for the second module and give it a unique name. So in this particular case, we're going to go ahead and give it a name of Station 1 for the first valve manifold. And we're going to give it a name of Module 1 because that is the first module that's installed in Station 1. We recommend giving this particular tag an underscore AOI for the tag name. So the full tag name will be Station 1 Module 1 underscore AOI. Just like previously, we need to associate the Ethernet IP name for this particular Station 1 valve stack. And since we only have one valve that is configured in this project, we're going to go ahead and borrow this particular input and output data structure by left-clicking on this and dragging and dropping it here into the particular target space for this AOI. We'll go ahead and drag and drop the output data as well. Next is to give the analog voltage module a config tag name. This is an important name that you will be using throughout your project. So in this particular case, we'll go ahead and follow the same naming convention by giving this a Station 1 Module 1 config tag name. So now when we want to use any of the available structure that's inside of this AOI in our PLC project, we will always refer to this as Station 1 Module 1. We will also need to configure where the module is located, and since all along we've been saying this is Module 1, we need to go ahead and indicate this in the AOI by giving it a target. This particular module location will be anything between 1 and 12. Calibration value is used if you want to adjust the analog settings. This is kind of like a tweaking value to fine adjust any voltages or analog noise that might be present on the system. As with all the other previous videos, we always recommend that once a tag name is created, to right-click on the tag name and click New Tag Name. This will ensure that the data type is correctly associated with the tag. Let's go ahead and create this in our project. We also have the one config tag name that we created earlier. We'll need to right-click on this one and create a new Station 1 Module 1 tag name that now is associated with this UDT. A UDT is a user-defined data type that holds all of the configuration information about this AOI, which is associated with the Station 1 Module 1 analog voltage AOI. Let's go ahead and create that now. Once we have created the AOI, we no longer see the error on this rung, and we are free to go ahead and download it. The calibration value is a value that we can use to tweak any analog adjustments that we need. In this particular case, we're going to go ahead and leave the calibration value 0 so that we can see the input information coming back from the analog ports. If you recall, we have an analog simulator that's attached to port 1 so that we can see the analog voltage value that's being read on port 1. Port 1 has an input port and an output port. Let's quickly review some of the parameter types that are associated with an analog voltage module. The input port raw value is a value that is going to be displayed in a range from 0 to 4096. This is where the analog module inside can be scaled appropriately for 0 to 10 volt or any other value that we want to reference. When we open up the tag structure, we're going to find something similar to this particular configuration here. You'll notice that in the manual that we have a chart here that references that some of the configuration value found in the UDT will not be used depending on which module it is. So in this particular case, when we expand out the Station 1 Module 1 .port 1, we will notice that there's an input 1 and an input 2 configuration. Because we're using the analog voltage module, these two memory locations are not used. So always refer to the manual that describes which particular tags and values are in use with this particular AOI. Now that we have our AOI imported and all of our tag names created, we can go ahead and save the Mac project and download it into our PLC. We can go ahead and select Communications here and then select Download. If our path name is correct, RSLogix 5000 should find the path name of the PLC and go ahead and allow a download of the project. We'll go ahead and download our new AOI that we added to our new project and make it run live. Here we already have some values that are being reported On the input port 1 raw value, you can see a value of 2175, which is a raw value that represents the voltage that is being fed into that particular port with our simulator. Our simulator is showing a voltage of 5.26 volts. Our particular simulator is not calibrated, so this will be a theoretical value that's being read and represented in this video series. Let's go ahead and look at the controller tags to see what we can see about our Station 1 Module 1 tag name. If we click on controller tags and find our Station 1 Module 1, we can see how this is broken down into the port numbers. Because an analog voltage module only has 4 ports, we will only be referring to the first 4 ports here, port 1 through port 4. The other ports are not used. We are using a common shared UDT structure that applies for all modules, regardless if the module is analog or digital. Analog or digital modules use the same UDT structure, so depending on the type of module will depend on which of the tag names that we're using. Always refer to the manual to see which tag names are being used. We can go ahead and expand the port 1 module to see what information we see about the particular Station 1 Module 1 port number. And here we already can see the port 1 input, which is a raw value represented as an integer value. This integer value is then converted into voltage. And here we can see that the module is reporting 5.31 volts on that particular input. The simulator shows 5.26. And this is where a calibration value might be handy. We can go into the front panel of the add-on instruction and begin to adjust the calibration value. This will affect the raw input data. We may try to put a negative value in here or a positive value to offset the actual raw input that is being read as an integer. If we return to the controller tags, we can see by putting a negative 30 in there has changed the voltage that's being reported. The voltage actually went up, 5.34. Whereas if we had a calibrated instrument and we were targeting 5.26, we would continue playing with the calibration value until we got the value that we want. A value of 60 reports 5.23. This has lowered the voltage down, and so forth. We can continue tweaking the calibration value until the voltage reads exactly as the calibrated instrument. Here we can see that we've selected a value of 38 integer to offset the 2174 that's being reported by the analog voltage module. And now inside the controller tags, we can see that we have an approximate voltage that is close to what the simulator is inputting of 5.26 volts. One of the best features about the add-on instruction is a feature called Scaled with Parameters. This is this SCP block that is being used inside of the analog voltage module. These 3 tags are the ones that will probably be used in your particular output. The point of an analog module is to read the voltage that's incoming and scale it to an output value that means something to us. So in this particular case, if this particular analog signal was a transducer that was measuring the stroke of a cylinder, let's say for example, the minimum stroke may be 1 inch, and the maximum stroke may be 100 inches. So then therefore 5.26 volts equals 53 inches of stroke. If we set this to 0, we have an exact representation of just a standard multiplier, where 5.26 volts equals 52.6 inches. Because we're using a scaled with parameter block inside of the AOI, we can set the minimum and maximum values for any range in between. the minimum range does not always have to be 0. We can go ahead and set this for 100 inches and scale up to 1000. And now we have 5.26 volts equals 573.51 inches. We'll go ahead and change this back to 0 to 100. Let's go ahead and adjust the voltage on our simulator. Here you can see that our simulator now shows 3.4 volts. This is a representation as if we had an analog transducer that was inputting 3.4 volts, which now means that the cylinder is located at 34.04 inches. Port 1 also has an associated analog output. The analog output works the opposite way, where we would go ahead and set the scaled minimum and scaled maximum value of a particular output voltage that we wanted to set. So in this particular case, let's go ahead and set a minimum stroke of 0 inches and a maximum stroke of 100 inches. And we want to set our output to 50 inches. When we do this, the output module then sets the raw value to an exact 2067 integer value, which is a representation of exactly 5 volts. If we wanted to move the cylinder, our virtual cylinder, to 25 inches, we would input an scaled output of 25, and now the voltage output of this particular port should be at 2.5 volts. If we had a voltmeter connected to that, we could measure this particular output. You will notice that because we're using an analog voltage module, that some of the information in the tag structure here is not used, as per what we said earlier in the manual. In this particular case, the digital I/O modules, the Boolean bits, Boolean input 1, 2, and output 1 and 2, are not being used. You'll also notice that because this is an analog voltage module, that the voltage tag is used and not the current tag. In our next video, we will be showing you the analog current, which is exactly the same as the analog voltage as far as setup and configuration, except for that it will be represented in a milliamp reading versus a voltage reading. Thanks for watching part 6 of this video series using an analog voltage module.